4, we're just going to calculate an IRR. On this one, the cash flows aren't funky, and so you probably don't have to think about calculating 2 of them. You probably won't have to guess, just from the way the question is structured. And to be honest, this is my first time to work this question. I can tell you right now, when it says what is the internal rate of return, there's only going to be one of them. And then the next one is the Utah Mining Company requires a return of 13% on such projects should the mine be opened. And so we're going to have to look at the NPV given a discount rate of 13% and decide whether or not to open the mine. All right. So it's going to cost this much to open. It's going to have an economic life of 11 years. It'll generate a cash inflow of $575 in the first year. The inflows are going to grow at 8% per year for the next 10 years. In 11 years, the mine will be abandoned and there'll be a cost associated with it. Okay, so let's just draw the timeline. You can do this from side to side, or you can do it up and down. I think I'm going to do it side to side just to be consistent. It's pretty far out there. Let's do it up and down. 0 equals that plus 1. Too many years. Okay, so the first one will be the year or time. The second one will be the cash flow. The third one will be the present value of the cash flow. And the fourth one will be the net present value. I'm going to make this a little bigger. Okay, the first year it's going to cost us $3.4 million. Let me make all these all pretty. Format, cells. $3.4 and then $575. $575, 1, 2, 3. They're going to grow at 8%, so equals that times 1.08. And I'm going to drag that down. There'll be some abandonment cost of $450 at the end of year 11. Rather than add a new column, which you can do if you want to, but then you have to sum across the column, I'm just going to subtract it here. Now I'm worried that I have the wrong number of commas. Okay, that looks right. All right, so now let's add a discount rate right here. I'm just using a dummy discount rate for the moment. We'll figure out what it is in a moment, or the real one. Okay, so the present value of this is that divided by 1 plus the discount rate. Let's lock that to the power of the number of years. Yeah, everything's cool there. Okay, so here's the net present value of the project given a 10% discount rate. What is the IRR on the mine? Okay, so again, to get the IRR, we're going to goal seek and figure out what interest rate, what discount rate gets the net present value to 0. So under data, we're going to go to goal seek. We are going to set the net present value equal to 0 by changing this cell. And we're going to hit enter and let her rip. It's 18.73%. So there you go, 18.73%. They have a return of 13%. And lo and behold, the present value is $1 million, almost $1 million. That means we should take the project. So 18%, it's unlikely that there's anything weird happening here. There's only one negative cash flow and it happens in the beginning. Most of these are pretty uniform. It leads me to believe there's only one IRR and that since it's 18% or 18 and change, and it's higher than 13%, then we're going to take the project. And we should see that. Yeah, he does a lot of math, but we're going to take the project.